Okay, it's 3 o'clock, and then we can start. All right. So um, I'll go a little bit slower since we have a lot of people that are connecting right now, and but it's good to start. So thank you, everyone. I am Ferdinando. I am the COO of Move Solutions, and it's a pleasure to have this webinar. We will talk about many different things. We will talk about dynamic monitoring, vibrational monitoring, and we'll speak about our technology and what we have in mind and what we are releasing right now. Okay, if you have any questions, if you have any questions that you may want to ask after the webinar, you can email us at info@movesolution.it. Also, you can raise some question. I think I'm able to see the question as well. So if you have any questions, you just pop a message, and that is fine. So let's see 1 second. Let me see. Okay, yeah, I can see the question if someone have it, so it's fine. All right, okay. So I say let's start this webinar. Okay, so as you know, as you guys are aware, we have a lot of complex infrastructure all over the world. From bridges to subway, underground dams, trains, a lot railways, a lot of different stuff, right? That we are enjoying using it, and it's helping us connecting anywhere, everywhere, and that is wonderful. Um, but besides that, the for what I can say, the most important things is that the infrastructure needs to be extremely safe. Safety, it's what is important. It's the most important things that we expect from our infrastructure. So we expect that when we driving on a bridge, everything is safe. We expect that the railways is completely fine even if it's raining, and especially we expect that the owner of the infrastructure can understand when an event occur, and the structure itself may change its parameters. So I'd say safety, it's what we really care about our infrastructure, that from dams, from a bridge, from railways, safety, it's the most important thing. So I'm showing this picture. We, as an Italian, as Italy have really suffered about the situation and infrastructure that we have. We have a hard environment. We have a complex, a really complex environment. Italy. Italy is also a seismic region, and it's really particular. So, for example, in close to Genoa, where there were the old Morandi Bridge that failed, and this caused a lot of death. There are a lot of, for example, a lot of infrastructure, a lot of bridges, because the geography, the environment, it's really particular. We have a lot of hills, so we need to have connected all these cities. So it's the government built a lot of bridges to connect different parts of different cities, and that's important. Um, when the this huge catastrophe happened almost 3 years ago, I was riding. I was going to France, and I passed on the Morandis Bridge I think on August 2nd. And, I just checked these enormous bridges, and I just passed through Genova. And then after, 5 days, everything went down, and, I heard the news. After that, I talked with my friends. I also talked with other people, and they said, I've passed to the Morandis 1 day before. Another person another my friend, he passed to the Morandi 2 days before. So what it means that we got really luck, stuff like that, failures, it cannot happen. And that's why it draws me to build a company which the system are able to understand and want to, predict this kind of failure. And that is really touching us. It's extremely important for us, and we want to bring it around the world. So that's what where we have, and I have started. Let's talk about problems. Okay, so if let's make an example. Let's say I own an infrastructure company which owns 300 bridges, thousands of kilometers of roads. Okay, so I'd say I have money to invest, and I need to invest the money because I need to make investment on the bridges to make it safer. I'm making an example on bridges, but I could do examples on railways, dams, tunnels. It's the same. It's just an example. My goal as an infrastructure company, I would like to know which one of the bridges is in the worst condition, and I would like to track the behavior of every kind of those bridges in a certain way, that if any of the parameters of one of these bridges change, I'll be quick, and I can make an action. I can take action, and I can go and check it. I can go and analyze why there is a change in that structure, and then I can do repair or actions to the structural part of the bridge in order to rebuild the other things. So it's extremely important for the infrastructure company to know which one of my infrastructure is safe or not. And beyond that, I want to be able to predict. I want to be able to understand if something is changed before it really change. Okay, before it goes to in a situation where it's unrepairable. That is, I think, the main thing that an infrastructure company would like to know. So there are, I think, some questions. Okay, which is the infrastructure that needs investment? So which is of my 300 bridges needs to be invested with money to make repair or other things? And the second is, how can I understand if my structure change behavior? That is really important. That is really important, especially also not only on bridges, but also let's speak about railways. Right, railways is so long, so there are a lot of pieces in the railways. I want to understand which one of the pieces is maybe changed. Maybe there is something that is going off. If there is a failure, I want to understand it. So right now we had the question. The question was, I do want to understand how something is changing. Okay, right. So there is a thing that I've discovered that is really particular. Okay, it is vibrations are really small, hard to understand it, but vibration in a certain way represent shows like a fingerprint of my structure. So vibration, I can see that if I have, for example, a beam which have some length, right? It will have, for example, some frequency. If I shorter the length of that beam, it will have another frequency. So you can understand that vibration can represent in a certain way geometrical parameter of my structure. And I can say that is a really hard, what I'm going to say, it sounds really hard, but in a certain way, I really can do that, is by monitoring vibration, okay, with some techniques. We don't know yet what is it, but by monitoring vibration, by monitoring, different things, different, by, let's say, listen how it moves, that bridge, how that bridge work, I could use those information, extrapolate some geometrical, right, parameters, and then track that. And that could be really powerful if you think about it, because I can measure, traffic, how traffic move my bridges. And then with that, I extrapolate some information that I use to predict how the bridge is, working correctly or not, or if this kind of vibration are changing, well, my geometrical parameter will change. So that means that maybe something is off with my structure. So that is a huge important thing that of what we're doing with dynamic monitoring in a certain way. By measuring vibration, I can go and understand how how the bridge is working, how my infrastructure is working. So that's really powerful. I found, going more technical now, so I found a document. We're speaking about the Morandi. So I went through, if you go check it from the Italian Minister of Transportation, you can see something really interesting. There was a document that it was published from the Politecnico of Milano, okay, from a professor, that couple of years before that the Morandi Bridge went down, he checked some parameters, some vibrational parameter, doing a technique called output model analysis. Basically, I check how vibration is moving across my bridge, basically. Okay, so that's the basic things. And I think when I've read it, I blew off, because the professor was saying, look, the shape of those vibration are completely asymmetrical. So in what he was saying on, if you read the relations that he did, is by measuring vibration, we understood that there is something not right. So we are asking to the owner of the infrastructure to check why there is this odd behavior, right? So then you can understand it, that this is incredibly powerful. With this technique, they were able to understand it, that there were actually something off, really off. Then please don't ask me why they actually don't do that. I really don't know, but that was on the paper 2 years before, actually, or maybe one or 2 years before that the catastrophe happened. So you can understand that with these techniques, it's really powerful. You can understand, especially if something starts to get off. If a bridge change his behavior by do this kind of techniques. So by measuring vibration, we said we got a kind of fingerprint, a structural fingerprint of my bridges, of my other kind of structure, and then I can extrapolate parameters with these that are really interesting and can show me if something get changed. And really interesting. There is a really nice technique. It's really interesting. So basically, what is the goal? My goal, the goal of my company, it's kind of using these techniques, dynamic monitoring, to predict failure before it happens, to predict changing the structure before it happens. That's what we are trying to do. So why dynamic monitoring? So we said, you know, a nice thing is we can extrapolate geometrical parameters from dynamic monitoring, right? Also, another thing is the finite element model that an engineer can do on my on a structure. It can be tuned using this parameter. So I can tune my model, my model, and check it if it changed, for example. I can use it to track behavioral, you know, to do anomaly detection. So I can use to track that. And in a certain way, I can estimate the change, for example, in stiffness. That is the really interesting parameter here. So dynamic monitoring, you can understand, is really powerful and really interesting, since you can use it to create model that represent your bridges and see how they change. Of course, I'm not, you know, it's not black magic. It's based on mathematical analysis. Um, there are limits, but those are it's extremely powerful technique. So now I think that dynamic monitoring will be, you know, the future in the monitoring probably of this infrastructure, by, you know, monitoring this vibration, monitoring this geometrical parameter. I can extrapolate interesting things. Okay, so that is a really powerful thing. Now, again, problems. We are a company that tried to solve problems, so we are having problems, right? So one of the huge problem is that we need to sample high frequency. Since we are you know, using vibration, since we are using vibration analysis, we need to sample a high frequency, because vibration, it occurs not so slowly, not so fast, but still you need to be able to sample at a frequency, you know, enough high to be able to see everything. So that is you need to have electronic systems which are able to sample at that frequency. So that's important. Second, so we have 300, right? Let's say 300 bridges. We don't want, of course, to wire 300 bridges. We don't want to wire 1,000 of kilometers of roads. We want to be quick. That's why we need wireless. We need wireless sensors that actually work on a long range. And then the problem is that when you sample high frequency, you have a lot of data. So you can see, if you sample, for example, 100 hertz, that means that you have 100 data per second. And then that 100 data per second, it will have a length, for example, in bits, because you're, you know, sampling from analog to digital. So you have a length in bits. So you can understand in 1 second, you might have a lot of data. And of course, to measure infrastructure, to do OMA, to perform those kind of measuring, you need to perform a longer analysis, not just 1 second. You need, you know, 43 minutes, a lot of seconds to be able to extrapolate information. The other problem is to perform output model analysis, which is one of the techniques that I've showed before. You need to have extremely synchronized sensors. So sensors need to be extremely synchronized between themselves, because if they're not synchronized, they will catch basically different part or different phase of vibrations. So that they won't then meet. That the problem is that it would if they're not in phase, you will estimate different basically shape of vibration along the bridges. So you need to be extremely synchronized. Okay. And 5, we need the algorithms, because we have the data, but again, those data needs to be evaluated. So we need the algorithm. Okay. So probably you are in that point that, okay, Ferdinand, it's 20 minutes that you're speaking. You're telling me I need high frequency sample system. I need a synchronized system. I need wireless. I need algorithms. Yes, I know that is hard, but the hard part is what we do. So that is what you need. What you need is having product that are able to give you dynamic monitoring and then static monitoring as well, because dynamic monitoring is really important, but it's important to measure really low movement. And then of course you need the complex algorithms to make all this kind of evaluation, and you need everything wireless. Don't worry, we are doing this. We are making everything really easy for you. We are making everything that is extremely easy, that you don't need to know about FDD, FFT, what is this? No, that's what Move Solution does. Move Solution, it's focused on providing the easiest senses, the easiest, the simplest senses, IoT senses that are able to do incredibly powerful analysis. That is what we're doing. And what we're giving is, the senses, the sensor itself, and the processing algorithms that can run on cloud, which extrapolate all these kind of informations. So how the system works? We have sensors. We have sensors on field. So the sensors are, on my bridges, and they can be installed in a couple of minutes. Really, you just need to place it on the structure. So that's it. Everything is completely wireless, so you don't bring any cable. And then you have outside, near your structure, but it can be found on another places, the gateway. The gateway basically receive information from the senses, and take the data and send it through the cloud or or to your system. So we have use cases in London, UK, South Pacific, USA, which basically the distance between the gateway and the sensors can be at miles of distance. So you can understand that you basically place your sensors where you want, and then you then have the gateway that receive this information that can be placed on a pole, or they can be placed on a wherever, to have this long range system which capture all this data basically. I'll tell you more about the LoRaWAN capability in 1 second. So as a company, again, what we're doing is we are designing the sensors. So we design everything. We design the PCB, we design the electronic, we design the firmware, we design everything that is made for structural evaluation. And this is a really concept that I would like to pass you, that sometimes, I have a bachelor in electronic engineer, and you think, oh, I know I can do, 100 hertz sampling is really easy electronic. We do gigahertz of sampling right now. It says, yes, that is correct. So we do gigahertz, but right now doing 100 hertz sampling, 125 hertz of sampling is really hard when you need to fulfill problems that are structural problems. So this means that basically you need to sample, you need to have sensors that work in a certain way that is really particular. And that is our know-how where we are investing in understanding which is the problem. If I want to do output model analysis, how my sensors needs to react. If I want to measure pressure, how my senses need to respond to that. And anyway, it's the process on how we are developing the things. We are developing the senses, but then we're developing the algorithms that will run with the data from the senses. That is the important thing that we're doing. Speaking about the system, so LoRaWAN is an incredible technology. I love LoRaWAN. LoRaWAN is a long-range wide area network protocol. So this means that you are able to exchange information on a long range. on a wide area network protocol. That means that basically the sensors are communicated between themselves on a this long range, but at the same time, the battery life, so the power that you use on communicate this information, is extremely low. This means that your sensor is able to run continuously, but using low power. And then when it needs to speak, when it needs to transmit information, will keep low the power that it will use. So that is the powerful thing on LoRaWAN, as you have a long range system combined with a low power basically system. So you're able to have the battery life of a sensor so long, even for 8 years, for example, if you sample really slow, but communicate on a long range. Okay, that is the thing. What it means that there is a fast installation with low maintenance cost, because the sensors always run, never stop until the battery life end. Okay, so that is the thing. Now there are people that might ask, yes, Ferdinand, I like the LoRaWAN, but isn't LoRaWAN for few sample? Is the LoRaWAN for a few data? And it says, well, yes, basically it is. But in Move, we decided to use LoRaWAN also for dynamic sensors. And what we have developed here is a disruptive technology that uses LoRaWAN. So we are 100% using on LoRaWAN, but we're able to synchronize sensors between itself without the GPS at 100 microseconds, basically. And on top of that, we are able to basically kind of compress the information and send all this kind of information on the network server, on the cloud, at high resolution, so like 16 bits for 125 hertz of sampling, and I send this huge amount of data using LoRaWAN. And he says how I can do it. Well, this is that part of our know-how. We are extremely focusing in developing the hardware, the radio, all the part to achieve that. So we use a complex technique called also channel activity detection. So many different things to be able to fulfill that. So what we're doing right now in the market is that we are bringing dynamic monitoring on wireless system, on LoRaWAN, on low power wide area networks. That is the incredibly things that we're doing right now. Let's speak about the product. Okay, so we love designing product. The first product that I have designed with my partner is the DEC. DEC is probably the one that have started the company, is designed for bridge analysis. How DEC work? Basically, what a DEC does, it sample continuously, so it never stops. But instead of sampling acceleration, or instead of sampling velocity, it sampled displacement. And he says, why I need to sample displacement? Because when your for example, load, let's say on bridges, a load hit the bridge, this causes vibration. Those in that particular moment, right, that vibration could be a little bit different than the expected vibration, and that is really interesting to measure that. And we said, let's not just measuring acceleration, because acceleration is really hard to understand. It's really hard to, okay, how, this is an acceleration, but how much in displacement that would be. So we said, let's do another way, and we designed the sensor to measure directly the displacement. And this is a displacement vibration. So that means that it's the vibration. So if I put my DEC in my hand, I would see how much I'm basically vibrating my hand. added really particular, and it's used for two things basically. DEC is used for dynamic monitoring on bridges and for for ballast void detection on railways. And those are the two main interesting area that we are covering right now as as an application with DEC. Because when, for example, when the sleeper is being hit by the train, it will make a fast movement, and that movement, the exact movement, DEC can understand it. So we can do ballast void detection by measuring those kind of impulse displacement that it always have. So DEC can be used also for that. We have run different kind of let's say we have run different kind of let's say tryout comparing with the radar from IDS, and we have seen that in the same bandwidth that the radar have and let's say and the DEC have, okay, in the same in the same bandwidth, the accuracy is extremely the same basically. So we got almost the accuracy of radar in that bandwidth, okay, that bandwidth. So because that it's not a widespread bandwidth, it has a limit bandwidth that is made exactly for that. Anyway, it will be out in the next month, another version with that will have a huge bandwidth that will be almost for static, almost static movement that will catch. So I think way more interesting also. But right now we have a lot of use case on infrastructure owner. They use DEC to analyze what happened when traffic is making vibrate my bridges. I've seen there are a lot of questions. I'm going forward, and I will answer everything at the end, okay? Then we have the triaxial tilt. Right, this is a static system. This is a more common system. Is plus minus 90 degree full scale, so basically 180 degrees. It has an incredible accuracy. On small rotation, you get an accuracy up to plus minus 0.001 degrees. So incredible one. And then I will show you how you can use the tilt to get the static deflections from bridges to can't twist from for the railways. Okay, let's speak again about dynamic system. We have the accelerometer. Okay, this is the new accelerometer. You can see how much I'm smiling here because my R&D team did an incredible job. So we are achieving a synchronization up to 100 microseconds with this instrument. It's incredible. We don't need the GPS. I can tell. You can place it on inside your building. You can place it in a tunnel, for example, and have synchronization sampling between each other. Of course, there are some limitations, but it's we think it's an extreme step over that we did. So we have designed the accelerometer to have two different firmware. One firmware is called the output model analysis firmware. Basically, is for structural analysis. So it's for to perform OMA, basically to perform output model analysis. So it will have longer sampling, for example, a couple of minutes, synchronized between themselves in the days. It will have also a threshold mode activation. So when the threshold is overpassed, it will sample just some seconds, and it is designed for OMA analysis. Another firmware that it will be out in some weeks is the vibrational firmware. The vibrational firmware is designed to basically control, verify if that your let's say how you say it, the threshold on limits on vibration are not overpassed. So you can set it will sample basically continuously, and when the PPV is overpassed, it will send you right a bars of information right to you extremely fast, and you can see the bars and the PPV that is overpassed. Okay, basically both of functionality are independent, so one firmware or the other firmware. But what we can do is there is a firmware update over the air functionality. What it means firmware update over the air? A firmware update over the air means that we'll may do change to one or the other firmware, and we can give you the chance to just update it as you update your smartphone. Just click a button and you will receive the update. Other two products that we have are the analog and digital nodes. Analog nodes are interesting. They can connect different kind of probes, more traditional, let's say traditional probes like 420 milliampere PTC, NTC, millivolt over volt probes. But then we have the digital nodes version. Digital nodes are really interesting because more and more there is a digital, let's say, instrumentation that need to be connected, and that this system fulfill all the needs for your digital probes that needs to be read. Okay, we are having, those are two products. They have the same price basically, and one is an analog node with four analog channels. By the way, every channel is independent between each other. So that means that on the first channel, I can do 420 milliampere. On the second channel, I can do PTC, for example. On the third channel, I can do again 420 milliampere, and program it as you want. So you can have different probes attached, okay? And the digital nodes has one channel, which is basically read all the chains of the instruments that are on the same chains. And then the gateway, the LoRaWAN gateway. So the LoRaWAN gateway is a traditional gateway. It have IoT connection, so you can send information on LTE or on the Ethernet port. We are making a new LoRaWAN gateway that will be out. That will have other kind of information, other kind of things, and we'll talk about in the next weeks again. That is a new product. It's an IP67. This LoRaWAN gateway is IP67. Is really strong. Is made for rain, for everything, right? So it can be outside. You can place it on the roof, on a pole, wherever. Okay, now we have spoken about the first part of what we said. I need to have the system that sample a high frequency synchronized between each other, right? Okay, but then we need, of course, the algorithms. We need the algorithms, how the algorithms work, how the platform work. So we have decided to build a platform. It's a cloud platform, but we have different plans for monitoring. So on the platform, you can find everything that you need. So you can find, you can go there and set the sensors. You can download the things. You can do everything that you need for your monitoring. Change the picture, place the sensors, and all the things. Okay, right. So that is probably everyone can do that, right? It's not a huge deal. But then we says we don't want a platform. We want an algorithm platform. Basically, on the platform that you have, you find tons of tools that I've built from our data scientists, which you can find FFT, statistical tool, FDD, frequency domain decomposition, and it's made completely easy to use. So you don't even need to know how an FFT is done. You don't need to do that. Our software, our algorithms do for you. For example, we have automatic output model analysis tool that extrapolate model frequency every day. So let's say you want to track the change in behavior on frequency using DEC. Basically, our tool just get the data of one day, of the day, and it extrapolates the FDD automatically for you. So you don't need to do anything. And an incredible thing is you can compare what he found. You can compare different kind of period, okay, using that tool. So it's extremely easy made. Another tool that is really interesting is you are able to analyze statistically your phenomenon. Don't forget that what you're seeing, what you're looking is statistical, is a phenomena that is never, cannot be all the time the same. It will change a little bit, but it will always change. So it's good to have a tools that you can use to analyze your phenomenon. And that is something as an electronic engineer, basically, electronic engineer work with the electrons. You don't see the electron. You build statistical model to understand how electron change, right? How they moves, and that's the same thing that we're doing here. We're bringing model, this statistical powerful model that they've been used in mechanical, electronic, and civil engineer, and we're bringing everything on the platform. Another tool that is usually useful when you do try to do to calculate the deflection of the bridge using tilts is the bridge deflection tools. So the bridge deflection tools is really interesting because you place the sensors, right? Let's say you are out, you're at night, and let me make an example. You are in England, in the UK, the highway England asks you, I need to do a load test tomorrow. So I will shut down I will close everything, I will close the bridge, and you need to place the sensors and do that. Extremely easy. You place the sensors. Just you need about 6, depending on the length, and then our tool will automatically fit the angles depending on the length. It does some magic, some analysis, and it will calculate in real time the deflection. So basically, every time that the sensors send you a data, you will see a change in the deflection in the deflection of the bridge. That is incredibly powerful, and that is it's extremely accurate. We have done compression using this kind of tools with total station, and the accurate that we got is basically the same. So it's really accurate. It's a really accurate system. Another tools that we have is an mathematical tool, is the railway tool to perform ballast void detection or to perform count and twist analysis. As you know, network rail, RFI, which is the railways in Italy, or other owner of infrastructure are asking you to perform. So the railway tool, you can build with the railway tool a track. Place the tilts, place the tilt beams. You might need a tilt beam, we don't know. And exactly we will perform all the evaluation on displacement on the graph and everything, okay? So it's automatical too. Those tools are designed to simplify your life. That is why we've done those. And then there are other tons of tools, algorithms, features that you can do with the system, okay? A lot of those. All right, the one question that it might come out is, look, Ferdinando, I like the platform, but I have a platform, right? It's understandable. The platform the Move platform is open. What open means, open doesn't mean it's free, but it means basically that you can connect directly, use MQTT API, FTPS, wherever, directly to our servers, and you will receive the information directly to your system. So basically, it will be kind of a gateway. It's the gateway they are pushing information directly to your system. That it's not something different than that. But plus, you have the APIs. You have the APIs to use directly our tools. Okay, that is the powerful thing. So basically, you can build other platforms. You can build other systems using our tools. And that is the powerful things. We want to be able to, that it's you that you're talking with the customer. We are a manufacturer company. We are not, fulfilling the needs, every needs of the customer. We cannot be on site everywhere. We are trying to do one thing right, okay? That is creating product, creating algorithms, and providing you with this. And what we like to see is that there are many companies around the world that build their services and give an offer to the customers, to the final customers, which are based on our algorithms, and they're showing their own information they want to show. They don't have to use our platform to show to the customer. They can just take the data and create their own incredible system. That is really behind what is behind all of the idea. We are not trying to do your job. You do the job perfectly. That is the thing that we're doing right now. So let's see the question. Let's see some question. Let me go. Okay. Okay, nice question. Do sensors need to be calibrated? And can we use any LoRaWAN gateway? Okay, yeah, nice questions. These are nice questions. So the sensors are coming from the factory already calibrated. So you don't need to calibrate anything, right? Sensors are already calibrated. We take out the offsets, we take out the gains, we make them already perfect to be used, okay? Can we use any LoRaWAN gateway? You can use any LoRaWAN other gateway that you like. You're not constrained to use to ours. It's just then we might need to set that gateway to be able to push the data. That is it. Let me go. Does the deck capture 3-axis displacement? Not. Unfortunately, it does not. It's not 3-axis, it's 1-axis. So you got or the horizontal plane or the vertical one. Deck, it's taught mainly to be able to check to check one direction. Okay, so that is the thing. Digital twin, yes, that is a thing that we are working with. We're working on many different projects, and we love digital twin. So for now, we are working also on the building information model to be able to bring it directly in our cloud platform. It's not out yet, but it's something that we do. So the other question are there are questions about regarding Indian LoRa frequencies. Yeah, we covered that. The LoRa, what is LoRa power sensors have? So I don't understand what is exactly the question, but the power we basically fulfill the regulation. So if the regulation, for example, in Europe is about 14 dBm, 13 dBm, we respect that. Okay, so we're not trying to go higher, and that we fulfill all the regulation that needs to be in Europe, India, Australia, North America, wherever. We respect all the regulation. We don't do anything weird, okay? So one question is, so the couple of questions about LoRaWAN. I see a lot of things. Okay, so another question is, I'm going I'm following the questions. So what about LoRaWAN network server? What can we send data to any LoRa network server? Yes and no. So we are working on that, so you can send the data to other network server. We need to configure anywhere manually that, okay? So it's not automatical that you just configure any network server. We are working with other network server operator like TTI or other to fulfill the needs of using other network server for the customer. Another question from an Italian guy? Love, there is I hope that you like the presentation. Is asking what is the frequency of the senses? So that depends on the senses. That can go from starting from 50 hertz to 100 hertz. The accelerometer, they have different sampling time that depends on the firmware. So from 100 hertz, and it can go way upper. That depends on if the firmware is OMA or vibrations. Another question is, LoRa standard for Europe are power and duty cycle limitation 1%. Yes. We have in Europe 1% limitation. The bandwidth is limited. There is a couple of things. We are respecting the regulation at 100%. 100%. So 1% bandwidth is 125 kilohertz, if I'm not wrong, and we are respecting everything. And then you ask, you are doing that by respecting everything? Yes, we are doing that. We have developed algorithms, software, firmware, the system to perform as that. Other question is still from the same person before, is how do you transmit continuously acceleration displacement? It doesn't transmit continuously. So they have threshold. When the threshold are overpassed, it catch 20 seconds before, 20 seconds after if it is the deck, or it's sample at some times that you can set, for example, every hour, every 2, every 3, every 5. So it's not continuously like run continuously, but you receive data, basically bars of data every couple of minutes. Okay, so you receive a lot of information continuously. So another question is about system detecting residual lifetime of the structure. Of course, there are a lot of model that is based on that. Okay, we are working with model that are presenting those kind of feature about lifetime of the structure, and we have one guy inside of the company which is right now focusing all the time, which is Paolo Dell'Ellis, which is a structural engineer. So if you have any question, we can talk with them and see how goes some questions. Another question is behind being bridge structure, can the system be used in other construction? Which ones? Of course. So yes, for example, deck again is meant more for railways or bridges, but accelerometers, TILs, analog nodes are made exactly for that. Are made for construction sites, so vibration on constructions, rotation on piles, many things. Okay, many different things. Another question is from UK. Are sensor network rail UK approved? Not yet. We are in the pathway. we have found companies that are sponsoring us on the approval, and we're really glad. I think it won't be, a slow thing. I think I'm seeing a lot of traction. So I'm sure that in the next month it will be out. So we are anyway working with the company that work with network rail for installation, I think. So we're not seeing any limitations. Can we purchase? How we can purchase the sensors? So we have dealer around the world, and you can purchase the sensors from them. If you have any inquire, you can ask us, and then we redirect you to our dealer. Okay, that is on your country. Okay. That was a lot. There were a lot of questions. I'm glad. There were other questions on the chat I can see. Okay. So okay. Edge processing. Okay, right. Edge processing. Okay, guys, if you make me question, I'll be there for all days, but I love to answer the question. So edge processing, yes. We don't do any edge processing right now. Just on the firmware for the other accelerometer, there is some edge processing that is there to capture a couple of things, and it is. Okay, let me see. Okay. All right. So we are ending our time. Okay. So again, I'm going to show you the email to contact. Okay. So if you have any question, if you want to book even a call with me, if you want to book a call with Toby Cottam, which is the UK sales director, or with Gilberto Braglia, which is the Italian director, or even you want to speak with technical people who are here to support. Our dealers are prepared, and they can give you all the information that you want. Last thing, okay, before leaving you guys, is that we are releasing a partner program. Which is a partner program? A partner program, it's a program that is created for partners to become to companies that work in the infrastructure monitoring industry or construction monitoring industry to become our partner. Okay, and what a partner means that if, for example, an infrastructure company or a structure owner company asks us, I need to do that job, we can pass the contact directly to you, and we can bring you at the table and so there is a network job opportunity, for example. Okay, so sign it up, ask us whatever information, and we'll be glad to answer. Okay, so again, we'll do other webinars. We'll speak about other things in the future. It's been a pleasure, 1 hour with you guys. I'm hoping to hear from you in the next month. Okay, thank you very much, and I'm hoping that you guys pass a great day and a great weekend. Thank you again. Bye bye.